In section 9 of chapter 2, we're going to be graphing exponential functions with individual transformations. This is the last paired function we're going over. Exponential functions are a little bit different than other parent functions because technically there's an infinite number, but I'm just going to go over 2 of them. Because exponential functions can have varying bases. The base could be a 2, the base could be a 3, the base could be a 4. So we need to do 2 of them so that you can hopefully start recognizing how to generate the rest. Once again, I'm going to make an XY table. And I am going to plug in numbers 3, 2, 1, 0, -1, -2, -3. When I plug in 3, that'll become a 2 to the 3rd power. That's 2 times 2 times 2, which is 8. So if you go right 3, 1, 2, 3, you're going to go up 1, 2, 3, 4, 5, 6, 7, 8. This is our dot right here. When you plug in 2, you're going to get 2 to the 2nd power. 2 times 2 is 4. So you're going to go right 2, up 1, 2, 3, 4. There's our next one. Then we're going to plug in 1. That's 2 to the 1st power. That means you have a single 2. So right 1 up 2. Then you're going to go 0, 2 to the 0 power. Now some people have trouble remembering what a power of 0 does to a number. But this chapter's all been about analyzing patterns. Let's analyze the pattern in the t-table. How do I go from an 8 to a 4? Divide by 2, half it. And then from 4 to 2, I do the same thing. Divide it by 2 or I half it. So if I want to know what 2 to the 0 power is, I should just take this and get half of it. It's 1. Which is why one of the golden rules in mathematics and algebra is any number brought to the power of 0 is equal to 1. And then negatives start showing up and students again start getting a little flustered. Like, oh man, how do I do negative exponents? Let's follow the same pattern. We cut the 8 in half to get 4. We divided the 4 by 2 to get 2. We divided the 2 by 2 to get 1. To get the next number, I'm just going to divide the 1 by 2 and get 1/2. And if I want to get the -2, I'm just going to cut the 1/2 in half and get 1/4. And I want to do it again, I'd get 1/8. Notice connection between these integer values and their negative counterparts. The first power was 2. The negative first power is 1/2. The second power is 4. The negative second power is 1/4. The third power is 8. The negative third power is 1/8. All negative exponents do is they get the reciprocal of the value if it was positive. It's my fancy math way of saying forget the negative, just get the number power and then flip it upside down. All negative exponents do is flip fractions upside down. Now here comes another interesting thing about exponentials. These are my next dots. They go like this and this and this and this. Notice the origin, which thus far has been the center of all of our functions. This graph does not go through the center. It does not go through 0, 0. We still mark it with an X. It's just no longer going to be a coordinate. It is still the center of the function. It's just not going to be something it passes through. Additionally, if you start following this function from right to left, you'll notice it's getting smaller and smaller and smaller and smaller and smaller and smaller, and it's getting closer and closer to the x-axis. But it's never going to touch the x-axis. It's going to get so close you won't be able to measure the distance between it really easily, but it will never touch it, which is when we introduce the idea of asymptotes. Asymptotes are locations that the graph gets close to, but does not actually touch. We utilize a dotted line to showcase this. Exponential functions are the functions that are the hardest to graph because there's a lot of little tiny bits you need to showcase. You need to showcase the center with an X. You need to showcase the horizontal asymptote, which goes through the X. And you still need to do the dots. So it's not just a graph, it's graphing also characteristics that if you just type this into Desmos or a graphing calculator, they won't show up. You need to be aware of those because we're going to mess around with that. Now lastly, I want to talk about domain and range. The domain of this function is where this exists in the x direction. It goes forever to the left, it goes forever to the right. That means the domain is all real numbers. However, the range, the lowest it goes is 0, but it's never going to be equal to 0. There's special notation we'll go over later, but technically the lowest it goes is 0, but it's not equal to 0, and it goes all the way up to infinity. Exponential functions are the functions that are the most impactful in your everyday life. Exponential functions show up all the time. If you're planning on going to college, these things will take a part of your life. You're either going to recognize them and respect them and know how to utilize them to your advantage, or you're going to ignore that fact and bad things are going to happen. Anyways, next one. Now I have y equals 3 to the x. Again, I'm going to do the same thing. X and y's, I'm going to do 3, 2, 1, 0, -1, -2, -3. This time I can go faster because now I understand what 0 powers and negative powers do. All right, if x equals 3, then I have 3 to the third power. That's 3 times 3 times 3. So that's 3 and 3 make 9. 9 times 3 is 27. That won't fit on my graph. 3 to the second power is 9. So if we go right 2, we're going to go up 9. There's our dot. Next we have a 1. 3 to the first power is just 3. So right 1, up 1, 2, 3. You have 3 to the 0 power. Anything to the 0 power is always 1. So it goes through right here. 3 to the -1 is 1/3. 3 to the -2 is 1/9. 3 to the -3 is 1 over 27. It's just the reciprocal of these numbers. So it's going to look something like this. All right, so it's going to get really, really, really close to the x-axis but not touch, and then it's going to grow really rapidly. The center is at the origin. There is an asymptote that goes through it.
Can you spell asymptote?
As best you can.